Hi there, you're in the lab with your mate JJ. Today is Maker Advent Calendar Day. We're going to kick off just a little digression here on In the Lab with JJ. For the next 12 days, we'll be working our way through this. This is the Maker Advent Calendar from the Pie Hut. I heard about this recently and it sounded like a bit of fun, so I thought that I might spend the tail end of this year just working through this little bit of Christmas kit. This is the 12 projects of Codemas. And I got it from thepiehut.com/advent. I'll put a link in the show notes if you're interested in looking at this yourself. My plan is to have a look inside it. I do not know what to expect, and just seeing what it's all about. And I'm planning to do one project from this kit every day for the next 12 days. That will get us through to Christmas Day. So we're going to start today and see what's in there, and then we're going to work through it for the next 12 days. Just as a little bit of a digression, we get to do some electronics projects. There are actually two Advent kits available from the Pi Hut. There's this one, and there's another one which seems to be about the Das Blinken lights, something to do with LEDs and glowing lights and this sort of thing. So there's two choices for project labs if you're interested in doing that sort of thing. But that's what you're going to be seeing around here for the next 12 days. We're going to do one project every day. And then once that's done, we'll return to our normal schedule, which is sort of recently updated. If you don't know, the schedule is, and off the top of my head, we've got Monday is Module Monday. Tuesday, we do Learning the Art of Electronics, where we work through the book with the same name. That's this monstrous tome here, which is from Thomas C. Hayes and David Abrams, with the assistance of Paul Horowitz, of course, the author of The Art of Electronics, which is the textbook. So Wednesday is sort of miscellaneous day. I do mail calls, interludes, channel news. Wednesday's sort of my free day to do anything I please. Then on Thursday is Maxitronics Day. At the moment, we're working through the Maxitronics 30-in-1. We'll keep doing that, pick that up again in the new year. Friday is book teardown, either a new book teardown or an old book teardown. I love doing both of them, but I particularly love going through my old books. I've got hundreds of old books. I managed to score the old silicon chip library, a large chunk of it. So got no end of old books to look at to see how technology evolved through the later half of the 20th century. So anything before the year 2000 qualifies for an old book, and we've got heaps of them to go through. So we'll be doing that again in the new year. Then on Saturday is our electronics project day. I want to make some time to do some actual electronics projects. My favorite type of electronics project is making a cable, the humble cable. I make heaps of cables. I have to make them all the time. And often you'll see me do that on a Saturday. And of course, I also do the Silicon Chip and JCAR mini projects on Saturday as well. I have been tied up with one of them, the third one, for like years. I'm trying to get it done. I've been doing it recently and I have problems with the MOSFET. It's not working. I don't know why. So I've got a bit of debugging to do there. And then on Sunday, the last day of the week, I do our cheat sheet review, and I've got some really great stuff from Quick Study, who make these really excellent cheat sheets. They're basically laminated 6 pages of notes on some sort of STEM topics, so mathematics, science, this sort of thing. Anyway, what we'll be doing today is figuring out what's in this thing. It's got some sort of a Raspberry Pi in it, I think, but I don't know what type. And then it's got one project for every day for the next 12 days. So let's pop over to the bench and see what we're in for. All right. Well, here we are on the bench, and this is our kit. As I said, it's from thepiehut.com. This is their Maker Advent Calendar, the 12 projects of Codemas. And there's a link there. I'll put that in the show notes. Apart from that, it's just blank. Manufactured by Nan Enterprises in the UK. There you go. So let's see what's in here. All right. So we've got the great big board. That's number one. And then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a great big honking one for the finale. Looks like it's going to be a little bit difficult to get out there. Maybe I'll try my tweezers. There we go. All right. Let's put this aside. I'm excited. Are you excited? Look at this. There we go. All right. What are we dealing with? Yes. Okay. So it's given us a breadboard and a USB adapter. Very good. Oh, there you go. And a little Raspberry Pi of some description. All right. There are no instructions here. Okay, so we're obviously going to need to get the instructions off the internet. That's fair. And can we get in here? What are we dealing with? Some sort of Raspberry Pi, apparently. This is a Raspberry Pi Pico H, copyright 2021. There you go. So we've got a little Raspberry Pi, a Raspberry Pi Pico. Not sure if it's got Wi-Fi or not. I don't know. Doesn't really look like it has Wi-Fi, does it? Are you seeing antennas or any sort of things like that? I think not. And it's given us a breadboard and a USB cable. All right. Well, I suppose we're going to have to go over to the computer together and find the instructions and see what they want us to do for the first project. So, shall I show you this quickly? If I zoom in here, this is the Raspberry Pi. Actually, I might even be able to show you better if I just, let me see. Give me one sec. All right, I'm back, and what we're looking at here is the board underneath one of the microscopes I've got here in the lab. Let me see if I can show you. So there we are, Raspberry Pi Pico H, copyright 2021. So it looks like this was made a couple of years ago. That that thing labeled debug there is some sort of a 3-wire header. I'm not sure what that is. Not sure. And then that's the RP2 B2. I'm not sure what sort of a chip that is. Obviously, it's the heart of a Raspberry Pi Pico, which I thought was the RP2050 or something. I'm not sure. It's all a blur to me, all of these micros and such. Yeah, this is okay. You got a boot select there, fair enough. And that USB is a USB micro. So yeah, there you go. That's everything to see on that side of the board. Do you want to have a look on the other side? It's just the back side of the board. It's not super interesting. Oh, there we go. So they've labeled a number of the pins there. That's great. MTCONN by the looks of it. Some 3.3 volt logic, and some GPIOs, a bunch of grounds. There you go. What are we? Oh, okay. So we've got DIO, ground, and clock. That's for the debug system. So I'm not sure what that is. I don't know. Do you know what that is? Some sort of debug interface. And then back on the top again. All right, cool. Well, let's go over to the computer together, and let's see if we can find out what the first project in the kit is. So let's go and have a look. All right. Well, here we are on the computer, and I've just gone to the piehut.com/advent, which has redirected me to the piehut.com/pages/advent. And as you can see, there's two choices here, and we have the red one. Let's see what it has to say. The Maker Advent Calendar If you're arrived at this page, it probably means you've got one of our super duper Maker Advent calendars. Lucky you. Please select the image of the Advent calendar you have below to go to that calendar's daily guide and contents page. We've got the red one, so let's see what it has to say about that. All right, the 12 projects of Codemas daily guides. So let's, what are we going to call it? Let's call it 12 projects of Codemas. Well, let's add it here. Add folder, 12 pages of Codemas, and let's just jump that in there. Okay, so I've got a link for later on. This page includes links to each day's guide for our 12 projects of Codemas, Maker Advent Calendar, which include component details, wiring guides and diagrams, example MicroPython code, and many examples on how to combine components from different days. All guides are available and ready to go. We also include a calendar contents section. Okay, spoiler alert, at the end of this page for those looking to understand what is included in the calendar before making a purchase. I have to say I didn't look at that. I thought that we'd let it be a surprise. So there you've got the 12 days and then you've got a spoiler at the bottom. Let's not read the spoiler and let's open up day one. So let's see what they have to say about that. Getting started. Welcome to the first day of your 12 projects of Codemas Advent Calendar. Excited? We are too. This 12-day Advent Calendar will teach you how to code with MicroPython using a Raspberry Pi Pico, using software along with a selection of fun, popular components along the way. We're going to use code to make hardware interact with the real world. Each day will show you how to use the fun things you find in each box, explaining what they are, what they do, how to construct a circuit, and then how to code them with MicroPython using simple methods. The best bit, once you've completed the 12 projects of Codemas, you'll have a Raspberry Pi Pico along with a great set of components with the knowledge and confidence to make your own projects with them. Day one, getting started. You'll have already noticed that the first box is larger than most of the others. This is to give you everything you need to build the foundations for the fun projects you'll be making over the next 12 days. Box 1, contents. In this box, you will find one Raspberry Pi Pico H with headers pre-soldered, one 1 meter micro USB cable, and one 400-point solderless breadboard. Today's project. Today, we're going to get you set up and familiar with the Raspberry Pi Pico, including installing the software required to program the board, as well as a running, that's a typo, as well as running a couple of very easy projects to get to grips with MicroPython. Okay. I haven't used MicroPython before. Frankly, I'd prefer to use C++, but I guess we're going to be using MicroPython. All right, introduction to the Raspberry Pi Pico. The Raspberry Pi Pico is a powerful, flexible microcontroller board from, you guessed it, Raspberry Pi. The same things who bought us a Raspberry Pi 5 and the Raspberry Pi Zero. The Raspberry Pi Pico is a different kind of Raspberry Pi though. It's a microcontroller board, not a microcomputer. The brain of the Pico is the RP2040 microcontroller chip, the little black square in the middle. Whereas you might use a Raspberry Pi 4, which has an operating system, to play games, write stories, and browse the web, the Raspberry Pi Pico is designed for physical computing projects where it can control components such as LEDs, buttons, sensors, motors, and even other microcontrollers. The board has lots of pins around it called GPIO, short for General Purpose Input-Output pins, which allow you to connect all sorts of components to make projects. These are controlled by code that you write
A map of the Pico's pins is available here. Let's open that. What are we dealing with? Oh, that's pretty handy. Let's save. I want oh, it must be a SVG, is it? Why can't I save page as? I just want to save the file. Oh, it's some sort of PDF. Ah, right. All right, well, let's download that. Where's the download button? There it is. Yeah, very good. All right. So this is the Raspberry Pi the Raspberry Pi Pico pinout. Say that 10 times fast. So we've got 1 to 20 and then 21 to 40. So there's 40 pins on this guy. We've got power, ground, UART, GPIO, PIO, and PWM, ADC, which is for analog to digital conversion, SPI, I2C, I2C, system control, and debugging. Here's the debugging pins. We saw those earlier. I don't know technically what this is, if it's JTAG or what, I don't know. Anyway, there we go. So we've got a whole bunch of green, which are GPIO. Yeah, wow. I'm not going to go through 40 different pins, but yeah, okay, a lot of options there. So let's go back to here. Okay, it says, don't worry too much about the different pins and labels just yet. We'll be covering over this over the next 12 days. The Pico can use many different programming languages. However, the most popular is MicroPython, which is what we'll be using over the next 12 days. The board has a micro USB port, which gives it power and allows it to communicate with our computer for programming. There's a lot more to this little board, but we'll keep to the basics for now. There's a picture of it, looks much the same as the one we've got. Software setup. We're going to install software called Thonny, which will allow us to program the Pico with MicroPython. MicroPython is a smaller, more efficient version of the Python 3 programming language, designed to be used with microcontroller boards such as the Raspberry Pi Pico. If you've programmed with Python previously, MicroPython will feel very familiar, but don't worry, we're going to guide you every step of the way over the next 12 days. Thonny is a Python IDE. An IDE is an integrated development environment. IDEs help us to write code by giving us lots of helpful features to avoid errors, make our code more readable, and provide lots of other benefits. So let's get Thonny. Head over to thonny.org and look for this little box. All right, well, let's do that together. Give me a second. All right, well, what I've done here is I've VNC'd into a Windows box that I've got called Verve, which is where I run my recording on the bench. And I've gone to thonny.org on a browser over there. So I'm reading the instructions over here on Proviso, and then over here I'm just logged into Verve. So let's have a quick read through thonny.org before we install the software. So it says over on the Pi Hut, it says, so let's get Thonny. Head over to thonny.org and look for this little box. Okay. If you hover over the system you're using, we're using Windows in this example, you should see some options with a recommended option based on the system you're using. For us, using a 64-bit version of Windows. All right, well, we'll download the Windows version because that's the easiest thing for me to plug in. On the bench, I have a USB-C connection, so we'll get an adapter for USB-C to micro USB. We'll do that in a minute. So we're just about to download the Windows version. Official downloads for Windows. So we've got the installer with 64-bit Python 3.10, installer with 32-bit Python 3.8. We've got portable variant with 64-bit Python 3.10, portable variant with 32-bit Python 3.8, and reusing an existing Python installation for advanced users. So we'll just be doing the first one there. That's all good. This is Thonny Python IDE for beginners. Okay. So it looks like there's a number of code windows there. Features. Easy to get started. Thonny comes with Python 3.10 built in, so just one simple installer is needed and you're ready to learn programming. You can also use a separate Python installation if necessary. The initial user interface is stripped of all features that may distract beginners. Right. No hassle variables. Once you're done with Hello Worlds, select View Variables and see how your programs and shell commands affect Python variables. Simple debugger. Just press Ctrl F5 instead of F5 and you can run your programs step by step, no breakpoints needed. Press F6 for a big step and F7 for a small step. Steps follow program structure, not just code lines. Step through expression evaluation. If you use small steps, then you can even see how Python evaluates your expressions. You can think of this light blue box as a piece of paper where Python replaces sub-expressions with their values piece by piece. Okay. Faithful representation of function calls. Stepping into a function call opens a new window with separate local variables table and code pointer. Good understanding of how function calls work is especially important for understanding recursion. Highlights syntax errors. Unclosed quotes and parentheses are the most common beginner's syntax errors. Thonny's editor makes these easy to spot. Explain scopes. Highlighting variable occurrences reminds you that the same name doesn't always mean the same variable and helps spot typos. Local variables are visually distinguished from globals. Mode for explaining references. Variables are initially presented according to a simplified model, name value, but you can switch to a more realistic model, name address / ID / value. Yeah, right. Code completion. Students can explore APIs with the help of code completion. Beginner-friendly system shell. Select Tools, Open System Shell to install extra packages or learn handling Python on command line. Path and conflicts with other Python interpreters are taken care of by Thonny. Simple and clean pip GUI. Select Tools, Manage Packages for even easier installation of third-party packages. And then they've got a demo here. We're not going to look at that at the moment, but you're more than welcome to swing by thonny.org and check it out. And then credits. All right, Thonny's main author is Ava Anamar. All design decisions and opinions are his own and may not reflect the views of the supporters listed below. All right, we've got the University of Tartu. From 2014 to 2018, the main development of Thonny took place in Institute of Computer Science at the University of Tartu in Estonia. Wow. Cybernetica. Since September 2018, development of Thonny is partially supported by Cybernetica AS and Raspberry Pi. Development of several features in Thonny 3 and 3.3 was proposed and supported by Raspberry Pi Foundation. We are also grateful for the help of several contributors from the open source community around the world. We've got instructions and downloads, installation instructions for Windows, for Mac, for Linux, pip install Thonny, back, wiki. Latest stable releases are linked in the download box at the bottom of this page. Latest stable releases are linked in the download box at the bottom of this page. Older releases and pre-releases can be found on GitHub. Plugins. Donny has simple infrastructure for extensions. These are some known Thonny plugins. Okay, so we've got Thonny Gitonic, adds a command for opening Gitonic. Looks like there's something that's been abandoned, the black format. Looks like it was replaced with the black formatter. Adds a command for formatting current file with black. Thonny EV3 dev allows uploading code to EV3 and much more. Thonny error explainer extends assistant with new error checkers. Thonny Labendus allows loading exercise from it's lahendus.ut.ee and submitting solutions for automatic assessment. Thonny Edison allows uploading Python code to Edison Educational Robot. Thonny Dracula adds Dracula syntax theme. Thonny OneDark adds OneDark syntax theme. Thonny Crosshair adds commands for invoking Crosshair Analyzer. Thonny iContract Hypothesis adds commands for invoking iContract Hypothesis Analyzer. Thonny Pi5 mode adds Pi5 support for a processing-like creative coding environment. Thonny Flake adds warnings from Flake 8. And Thonny Autosave adds the option for auto-saving your script every 10 seconds. Note that Thonny developers are neither endorsing nor responsible for these plugins. Contact and news, so we've got changelog, forum, mailing list, issues, GitHub discussions. And there's some papers here. Thonny, a Python IDE for learning programming, and introducing Thonny, a Python IDE for learning programming. There you go. So let's download the Windows version. There we go. And let's run the installer. For me only is fine. Thanks very much. All right. Welcome to using Thonny. Let me make that bigger. No. Welcome to using Thonny. This wizard will install Thonny 417 for your account. 417. Okay, this was 401 that they had at time, so it's an upgrade since the documentation was written. The MIT license, great. We're gonna install it in the default place. Sounds good to me. At least 122 megabytes. That shouldn't be a problem. Start menu Thonny, sure thing. Create desktop icon, yeah, sure, do that. All right, ready to install. Setup is now ready to begin installing Thonny on your computer. All right, click install to continue with the installation, or back if you want to review settings. Installing in my app data folder. It's going to add stuff. Easy peasy. All right, so there goes the installer. Looks like a lot of third-party stuff. All right. Okay, compiling the standard library. That's interesting. All right, Thonny is now installed. Run it via shortcut or right-click a .py file and select Edit with Thonny. Programming isn't about what you know, it's about what you can figure out. Programming isn't about what you know, it's about what you can figure out. Chris Pine. Very good, Chris. All right. So, doesn't look like it's going to run it automatically for us. Has it put it somewhere? Where is it? Looking for Thonny. Are we seeing Thonny? You can see it, can't you? And I can't. Where is it? Arduino. There it is. All right, let's add him to the. Okay, we're gonna run standard. Oh, does it say? Let's see what it says here. If you hover over, actually, I'm gonna go make more coffee, and I'll be back in a second. All right, I'm back. I've got my coffee, and I'm ready to proceed. If you hover over the system you're using, we're using Windows as an example, we already saw this. You should see some options. We recommend option based on the system you're using. For us, using a 64-bit version of Windows, it's recommending the 64-bit version. The version number may be different. This is fine. Your system may be different, so it's best to just go with the version the website recommends. All right. Download the correct version for your computer and open the file to start the installation. Following installs like most programs, we will ask you to accept the license agreement and confirm where to install it. We kept all the options as default and it took just under a minute to install. Once installed, select Finish and then open the program. In Windows 10 and Windows 11, you can select the Windows Start button and just type funny. The program should open and look like the example below. All right, well, it didn't give us any indication about what we should choose here, if we should use standard or Raspberry Pi simple. What are we going to do? We're going to have to make a decision. Let's use Raspberry Pi simple because we're using a Raspberry Pi. I don't know. Don't know. Let's keep reading a bit. Install MicroPython, blah, blah, blah. We're now ready to install the MicroPython firmware on the Raspberry Pi Pico. I'll tell you what, I'm just going to leave this as the default, which is standard because it didn't say anything about it. English USA, that's fine. Let's go. All right. So let's just try pinning that. And if we close that, it's still there. Open that. Okay, Ripper. So it looks like we've got a little thing here. Okay. We now need to install the MicroPython firmware on the Raspberry Pi Pico. This gives the Pico the basic software it needs to run MicroPython and code that we'll send to it later. Important note, a handful of customers are experiencing an issue when using the method we have suggested below, SSL errors and other unfestive nasties. Give it a try, but if you are having trouble installing MicroPython for your Pico, try the other method here instead. Thanks to everyone who let us know about this issue. All right, so there might be a problem. We've been given notice. All right, plug the Pico into the breadboard, the end where the number 1 is. All right. Then plug the micro USB cable into the Pico. Your Pico should be fully inserted so that you can't see any of the metal legs or pins. The black plastic on the underside of the Pico should sit flush with the top of your breadboard. Apply strong pressure evenly at both ends. Okay, we'll do that in just a tick. Now locate the little button on the top of your Pico. This is the boot select button, which when held in whilst connecting the cable, allows us to install different firmware to the Pico. Hold down that button whilst plugging in the USB cable to your computer's USB port at the same time. You may see it pop up as a new device on your computer, but just ignore that for now. In Thonny, at the bottom right-hand corner, you'll see something like MicroPython, Raspberry Pi, Pico, and a COM port, like the example below. This may vary, but it doesn't matter at this stage. Click on this and you'll see a few options. Select Install MicroPython. All right. I wonder if we can do that together. So what are we going to do? All right, let's go over to the computer together. We'll stop here for a bit.
All right, so you can see the Thonnies on the left there, and you can see the desktop up back. So we're just going to try and install this. Let's put in there, and we want pin 1 here. Very good. That looks pretty good to me. Push hard to get him in. There we go. Now we've got a USB micro. So what we're going to need is just a USB-C to USB-A. I'm sure we will have such a thing. That's the wrong way. Can we do... Not seeing what I'm looking for. No. All right. Well, I'll go digging in another box. I'll be back in a sec. All right. Well, I found this. It's a USB-C to USB micro adapter. So we should be able to get that to plug in there. And then we should be able to get that to plug in there. And what's happening? Are we going to see anything? All right. RPi, RP2. Select what happens. So we're just going to ignore that autoplay there at the moment. All right. Now, was there any... okay, looks like... okay, we've got COM7, ESP32, ESP8266. All right. So let's go back over to the computer together. And what did it say? Sorry, I'm just on the computer now. Okay, install MicroPython. Oh, you have to hold down the key while plugging in. Okay, so let's try that. So we're gonna just unplug him. All right. Now we're gonna hold down the button while we plug it in. All right, I'm not sure if that made any difference to anything. I don't know. Let's try install MicroPython. Okay, install or update MicroPython UF2. All right, I'll tell you what, I'm just going to throw you back over to the computer and we'll keep on keeping on.
All right, I'm back on my other computer now. Let's see what that says. Can you read that? Install or update MicroPython UF2. Here you can install or update MicroPython for devices having a UF2 bootloader. This includes most boards meant for beginners. Put your device into bootloader mode. Some devices have to be plugged in while holding the boot cell button. Some require double tapping the reset button with proper rhythm. Well, let's hope that holding the boot cell worked. Wait for a couple of seconds until the targeted volume appears. Select desired variant and version. Click Install. And wait for some seconds until done. Close the dialog and start programming. Okay, so the target volume is what's called D drive. Very good. The family is RP2. Okay. MicroPython family is okay. RP2, SAMD21, SAMD51, ESP32S2, ESP32S3, and RF52. All right, RP2 variant. Okay, well, let's install Pico H. Does it say over here what we should do? Oh, yeah, it does. All right. So we're going to install Pico H. Very good. Look at, there's a whole lot of variants. Wow. Shall we have a close look? Why not? So the most popular are Pico and Pico H, and there's Pico 2, Pico 2W, and Pico W, Pico WH. Okay, so there's a lot of different Picos there. All variants. We've got Adafruit Feather, RP2040, Adafruit Itsy Bitsy, RP2040, Adafruit Cutie Pie, Cutie Pie, very cute, Cutie Pie, RP2040, Arduino Nano, RP2040 Connect. I don't know what the Arduino Nano and the RP2040 have to do with each other. It's a mystery. Mac H-Dyn. MacDyn. Looks like German. McHobby. McHobby. RP2040. PyB Stick. Nullbits. Bitsy Pro. Pimaroni. Badger 2040. Okay. So I'm not sure what Pimaroni is, but there looks like a bunch of options there. Pololu. I'm sure what that is. Raspberry Pi. Okay, so these are in the most popular section up the top, which we're going to choose. It's like a bunch of options for our Pi. Seed Studio, XIAO RP2350. Okay, the 2350 is the new version of the Pico. Spark Fun, IoT Node, Pro Micro, Thing Plus, XRP controller. Oh, there you go, WeAct Studio. Very good. 20 RP. I've got a lot of the WeAct boards actually. They're just cheapo knockoffs that you can get on AliExpress. It's good that they've got some support. I might look at that someday. WeAct Studio. WizNet. All right. Now, it did say use the Pico H, didn't it? It did. And they had version 1.26. And we've got version 1.27. No reason not to use the latest, I guess. Info. There we go. Let's see what happens if we open that. Micropython.org. Download RPi Pico. Vendor Raspberry Pi. Features dual core, external flash, USB. Source on GitHub. More info on the website. All right, let's drag that into our links. All right, installation instructions. Flashing via UF2 bootloader. To get the board in bootloader mode ready for the firmware update, execute machine.bootloader at the MicroPython REPL. Alternatively, hold down the boot cell button while plugging the board into USB, which is what we did, by the way. The UF2 file below should then be uploaded to the USB mass storage device that appears. Once programming of the new firmware is complete, the device will automatically reset and be ready to use. All right, and then we've got a bunch of firmware releases going back to version 1.14 from 2021. And there's some preview builds available. There you go. These are automatic builds of the development branch for the next release. All right. Well, let's minimize that and let's continue here. Install. What's it going to do? It says it's doing a thing. Waiting for the port. Done. All right, so we can click close. What have we got? All right. All right, says once complete, setting up Thonny. Thonny can be used with a range of development boards, so we need to tell Thonny that we are using a Raspberry Pi Pico. From the top menu, select Run and then Configure Interpreter. Run, Configure Interpreter. Alright. Now just make sure that MicroPython Raspberry Pi Pico is selected. We've got local Pi. Alright, what do we want? MicroPython Raspberry Pi Pico. Alright. So it says here, which kind of interpreter should Thonny use for running your code? Details. Connecting via USB cable. Connect your device to the computer and select corresponding port below. Look for your device name, USB serial or UART. If you can't find it, you may need to install proper USB driver first. Connecting via WebREPL. If your device supports WebREPL, first connect via serial. Make sure WebREPL is enabled. If import WebREPL setup, connect your computer and select OK. I reckon we're on COM7. What do you reckon? I reckon we're on COM7. Could be COM8 though, I'm not sure. What's CDC? I'm not sure. Let's say COM7. Let's give it a go. Interrupt working program on connect. Synchronize devices real-time clock. Use local time in real-time clock. Restart interpreter before running a script. Alright. Okay, so make sure that Pi Picos, select the available thing. Tip, if you see multiple options in the port drop-down box, it just means you have other devices connected to your computer. If you're not sure which one is the Pico, make a note of what COM ports are showing, disconnect the Pico from USB port, close the Thonny options box, then try again. Whichever one is now missing was the Pico. So shall we do this together? Let's do this together. So let's click cancel here. And let's close this and just unplug this. And then let's run Thonny again. So, and we'll click run, configure interpreter. And we're going to choose Pi Pico. And we're going to not, okay, so COM7 is there. Okay, so we've got COM1, COM7. COM1, COM7. All right. I'm going to hold down the button and plug him in. Okay, we've got D drive. So let's run Thonny again and run configure interpreter. We're going to choose Pi Pico and oh no, we've only got COM1 and COM7. Shall we try again? Run configure interpreter, Pi Pico, COM1, COM7. Okay, I wasn't expecting that. Let's see what happens if we try COM7. Use Control-C to interrupt current work. Reset the device and try again. Check connection properties. Make sure the device has suitable. Make sure the device is not in bootloader mode. Not in bootloader mode. I thought it said it wanted it in bootloader mode. Okay. Well, let's try putting in not in bootloader mode. So we'll unplug this and we'll plug it in and we won't hold down the boot select. There we go. And let's run Thonny again and run configure interpreter. COM8, there we go. Board CDC. Very good. Okay. All right, seems like we're in. Let's keep reading over here. Okay. If you see, okay, so it was COM8 CDC. Oh, there we go, board CDC. Tip, If you see multiple options in the port drop-down box, it just means your other device is connected to your computer. We read this before. If you're not sure which one is the Pico, take a note of which COM ports are showing, disconnect the Pico from the USB port, close the thunding option box and try again. Whichever one is now missing was the Pico, so connect it again and select that device next time. It's a lot easier than disconnecting everything else. As of September 2025, our Pico shows as board CDC at COM9, but that last number will be different for everyone. All right, so it was the CDC board. Got it. You shouldn't. Sorry, I was just checking the microphone's working. It seems to be working. Okay. So, you should now see a Raspberry Pi Pico on the left side of Thonny. What's it? Oh, here. MicroPython Raspberry Pi Pico. Right. Okay, that seems to be working. And information in the bottom right and the shell panel. Yeah, there's the shell panel. If you don't see your Pico on the left, try selecting View from the top navigation and selecting Files. That's the setup out of the way. We're ready to code. All right, let's see. So activity 1, your first program, print. Let's make a very simple program and run it on your Pico. We'll tell the Pico to print some words, known as a string of text. These words/strings are then printed to the shell window. The print function is something you'll use a lot when programming. It's a useful tool to see what's happening with the program, what part of a program is running, and can help when debugging projects. In the top panel, which should be called Untitled, it is, at the moment as we haven't saved it yet, copy, paste, or enter the following line and select the green run icon. It looks like a play button from the menu. I don't think we're going to be able to copy this, but let's see. No, but we can print. Oh, are we putting that? Oh, we're putting it in the code. Okay. Print. This is my Pico talking. It's supposed to be hello world. What's wrong with you? You should now see the following in the shell window. Okay. So can I? Oh, okay. Let's save it. Where are we going to save it to? Oh, that's interesting. You can actually store it on the Pico. Sure, store it there. Advent 2025 01.pi. What do you reckon? Advent 2025 01 pi. Okay. And I saved it on the Pico itself. That's cool. Now you can do that. All right, now let's press go. This is my Pico talking. Kick ass. You did it. Your first program. Yeah, okay. A few things to note. Print text strings always sit within inverted commas within brackets. Letter case is very important with MicroPython and other languages. Our print is always print and never print with a capital P. Now try changing the text in between the inverted commas. You can write anything you want. This calendar is going to be awesome, or I don't like pineapple on pizza, or even the famous hello world. Yes, of course. So let's do hello world. Save, play. Hello world. Great. Okay, this is activity number 2. Okay. So this is okay, so there's multiple activities per thing. So let's go file, save as Raspberry Pi, and then that, and we're going to have -2. Okay. We now know where to write code in Thonny and how to run a program. We'll be doing a lot more of that over the coming days. So for now, let's jump straight into a bit of Blinky. Okay, we're going to blink the onboard LED. Great. The Pico comes with a little LED on board, which is attached to one of the Pico RP2040 pins, GPIO 25. This pin isn't one of the physical pins available around the edge of the board. We can tell our program to turn this pin on or off whenever we like, which is a nice, easy first hardware project that can be handy as an indicator for your own projects later on. This is the beginning of getting your code to control physical things. All right. Inputs and outputs. Our GPIO pins, the green ones from the pin map. If you remember our pin map, we saw that earlier. So the GPIO ones are all of the green ones. Very good. Can be set as inputs or outputs. We use inputs when we want something to send signals or voltage into the Pico, like a button or a sensor, and we use outputs when we want the Pico to send signals or voltage out to something else, like LEDs or buzzers. We're going to use an output here, which will send voltage to the onboard LED to light it up. We're going to use an output which will send voltage to the onboard LED to light it up. Inputs. Take a glance at the first line of the example code below. When we write code in Thonny, a lot of the time we need to add imports at the start. Imports bring in code from other places called modules or classes, but let's not get bogged down with that for now. That we need to make our program work. Usually these are from built-in modules. To use the GPIO pins, we always need to import pin, the code. Take another look at the example below. So what is it doing? Okay, so from machine import pin, onboard LED equals pin 25 pin.out, onboard LED.value 1. All right, let's do that. From machine import pin, onboard LED equals pin 25 pin.out. Is it going to give me auto completion? Yep, gave me completion. That's pretty good. And then onboard LED dot. It's going to give me some options. Value 1. Okay, so I've saved that. Copy that code to your top right panel and then hit the run button. All right, here we go. Run. Up there it is. The green light went on. I thought it was going to be red, but it's green. Fair enough. All right, let's turn it off then. Let's just take that and write 0 and hit run. And there it goes, the green light turned off. Shall we flash it? Let's wait. Oh, there we go. Okay. Copy the code to your top right panel, then hit the run button. The LED should light up. Hooray, you've controlled your first physical component. Now try changing the 1 to 0, which we already did. Run the code again and it should turn the light off. You can also try adding a print line at the bottom to show a message at the same time. Print. The LED is on, baby. All right, so let's save that and let's run that. And the LED is on and the message is there. All right, day 1 complete. Well done, fellow maker. Today you have become an owner of your very own microcontroller, learn about the Raspberry Pi Pico, set up your Raspberry Pi Pico with Thonny, created your first program, learn about the print function, control a physical component with code. Now, get some rest and a good night's sleep. For tomorrow, we will continue the fun with day 2. no spoilers here, and no peeking until the morning. We used fritzing to create the breadboard wiring diagram images for this page. Oh, that must just be on every page because there were. Oh no, there was a breadboard wiring, wasn't there? This one maybe. This one. That must be what they're talking about. Right. Anyway, we got all the way through to the end. So I guess I'll throw you over to the farewell cam and we can wrap up.
And that's a wrap. So there we go. We got through our first day. It was box number 1. It had 3 things in it. One of them was our Raspberry Pi Pico H, which is based on the RP2040 microcontroller. Incidentally, that's not the latest one. The Pico 2 has a newer microcontroller, so this is old tech by now. But still good. It comes with the programmable I/O as well, which I'm interested in checking out. So good to have that. Of course, I have Picos already. I've got them all over the place, but we've got a Pico here. They gave us a breadboard, which was nice of them. Of course, I've got a bunch of them as well. I found a USB-C to USB micro adapter, which is good because I couldn't find an adapter for the Type A thing. Actually, I'm going to jump over the computer and buy those now because next time I go looking for them, I'd like to have them. Anyway, this USB A to USB micro cable is surplus to requirements, so I'll be putting it in the drawer, and we'll just use our little adapter here for projects going forward. That's everything for today. I suppose we got set up, we got everything plugged in, we got the Thonny IDE installed, we tested things. It's all going gangbusters. So yeah, pretty happy about that. And stick around because over the next 12 days we'll be doing one project every day. Yeah, that's the end of this video. So I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.